Sorry. Okay, here we go. As Drew said, I'm Chris. I'm also on Twitter as Code Soda, so if anyone has any questions they'd like to shoot out after the presentation, feel free to hit me up. My background originally was in software engineering and microelectronics. I worked for a long period in enterprise engineering teams and then caught the startup bug. And so this is now my 5th startup. I previously sold 2, which were both in the security space, but in physical security. And so my forte these days is bridging the practices between engineering and security teams. So to sort of sum that up, I spend way too much time around security people while also trying to build things. So at Bugcrowd, we provide a platform and a service that helps companies get better security feedback for their applications. So we basically connect freelance security researchers to companies so they can run public and private security programs. And you can see a few examples of the companies that we work with here. So a few things that we'll cover today in the short 25 minutes that we have, DevOps and how it can be a double-edged sword, how to introduce security into your DevOps process, reducing the friction between the teams that are involved in this process, and also accelerating the return you can get on this investment. So let's just look at why we're all here today. So we all want to build better apps, and we want to work to be better together within teams and then amongst teams. And we definitely don't want to get hacked. So just look back at how we got here. So if we flash back to 1995, everyone was wearing flannels. Actually, everyone's still wearing flannels if you're in San Francisco. But this is what was normal. Organizations had a single corporate network, and from a security perspective, they were just trying to build the biggest fence around this that they could. So you have some internally hosted applications. You bought some hardware gear to stick in a rack, and software was released every month. If that, and it mostly kind of worked. So if we fast forward now to 2015, it's really different. So proliferation of cloud, mobile, SaaS, it means that your business data is everywhere. So regardless whether you've got 100, 100,000 or 100 million users, I assure you there's someone or something that's poking at it. And on the other side of this, you look at the new development methodologies such as agile and distributed systems, service-oriented, microservice type architectures. Applications and systems are getting more and more complex all the time. And the thing is, it's no longer about the corporate network. Everybody's businesses are interconnected. We're building the internet, but we're also part of the internet. We're actually writing and pushing code faster now than we've ever had before. And what used to be monthly release cycles can now be measured in hours. And the thing is, code isn't just running on our own servers anymore. It's code that's running inside and outside of our networks. So this big fence, it just doesn't work anymore. So let me introduce a new normal. This is where the idea is to strive to reduce bugs and vulnerabilities before code hits production systems. So the philosophy is move the security as close as possible to the code and the data. So this idea, coupled with tight feedback loops, means we're in a much better position to support our ongoing complex new ways of building and deploying software. So let's look at DevOps as a double-edged sword. So with or without a security focus, DevOps can bring a large number of really high-value things to an organization, but there's a few things to consider. DevOps and security teams all have different goals. So developers, they're incentivized to build innovative new apps and features. And this is generally, unfortunately, timed to meet sales and marketing deadlines. So security, performance, usability, robustness, it's generally missed out during this build process. Look on the other side at the ops team. They're concerned with making sure nothing breaks. They want solid, stable systems that never go down and their customers are happy. And unfortunately, this typically means don't change anything. So now look at the security team. They're the exact opposite. They're let's break everything. Let's point out what's wrong. Let's go and tell everyone you've done everything wrong and this should all need to change. And the thing is, honestly, this is how security people are and they enjoy it. And I would too. So if all three of these teams are incentivized in different ways, it's almost like it's forcing them to act as adversaries, and this isn't a good thing for business. So if we look at DevOps and its emphasis on rapid change, this can become a breeding ground for bugs and security vulnerabilities. So without well-established feedback loops, it's really going to hurt your business and even more the people in these teams. So the big secret here is start simple. Take small steps and earn easy wins. If you try and add all of these things at once, you're going to fail. So how can we introduce DevOps with security? So the thing to remember here is that a developer's job isn't just to write code. It's about writing running software that works well. It needs to be reliable and it needs to be secure. So if we build QA and security into this process, ideally in an automated fashion, we can establish these really simple feedback loops that bring this value. So the first big goal is to have a dev team that cares about their code in production. And so, like, if anyone's ever tried this before, it's a big feat. And so the first real step before that is to get developers to care about their code during development, when they're actually writing it, when a new feature is added, when a fix is created. And they need to feel the love. So this code, this should be your engineering team's baby. They should defend this thing. No one calls their baby ugly. Like, they should treat it like their firstborn. They go to the pub and they talk about this stuff. And so if you don't have any of these processes in place yet, then the bare minimum you really want to start with is to get peer code reviews. And Git pull requests are the best way to do this. This helps to spread the knowledge. You've now got individuals who are seeing what other people are writing. They're working on things together. You can identify bad practices really early on and get a discussion amongst that team on, hey, what are we doing wrong? How can we improve? How can we do better? Then the next step is to introduce a test-driven development environment where they're using a continuous integration server to run these tests every time code's committed. And this can sometimes sound a bit like, yeah, okay, I've read that book, I've done all these things. But the truth is that so many companies still inconsistently do these things. And you'd be surprised at some of the companies who actually still don't do this well. Doing this well will become the roots of what's going to become your, a really tightly integrated with tight feedback loops between dev, ops, and sec. And once you've got these things established, extend that automation. It's not just about running code tests. And encourage your team to do more testing and more reviews. So the idea of like a code style and quality testing, it is security testing. If the code's complex and hard to read, it's going to be hard to review. And ultimately, it's going to be hard to fix. Introducing static security analysis with any one of open source or commercial tools helps to catch any of this simple low-hanging fruit that's in there and identifies early on any implementation issues. And this last item, which we love ourselves and we do it very much internally, is introduce abuse cases. Like have your product owner write or a security team write malicious user stories. Say, when someone does this bad thing, the application doesn't do something bad. It's a great way to make sure that security issues don't regress, and they also are great training material for new team members. I mean, overall, like having a focus on quality and then having a precedence on testing always will rub off on security of application, whether it's code, infrastructure. And so the big thing here is that everyone now needs to care about this process. So like your dev, ops, and security teams, they now all need to be brought into the idea of using collaboration. It reduces friction and increases the velocity of these teams. One of the best ways to implement this is to instigate a firefighting team. And so we do this ourselves. So on a weekly rolling basis, take a few members from the dev, ops, and sec teams to work together. So they're still with their original team, but they're working together as a single team as well. They all get to see the issues that come up for each other, and they actually help each other resolve them. So what this does is it provides a deeper understanding of what it actually means to be on that different team. It lets them naturally see how they overlap. They get a much better understanding of what these people in the other teams need. And after introducing CodeLove, this is the second most important feedback loop you can introduce. So the big thing with friction is that teams don't want to talk to each other. And if you can reduce that barrier, people will be much more comfortable in approaching each other. If a member of a team can't engage someone else in another team, then that other team might as well not exist because you're not going to get the value from that collaborative workflow. But luckily, that firefighting team is a great way to encourage this cross-pollination and let them feel each other's pain. I mean, because ultimately, you've hired smart, capable people. So like show them each other's problems and they'll start to naturally introduce solutions. So a big thing here is the size of the security team is generally somewhat insignificant compared to the size of your engineering team. When you ask the security team to protect your entire application, being like the code and the infrastructure, it's really an unfair fight. Whether you've got 5 engineers, 10 engineers, 50, 500, this doesn't compare with having 5 security engineers. And so now look at what your security team does when they interact with devs and ops engineers. They have to monitor infrastructure, they're reviewing code, but they're also protecting the sales and marketing team from like phishing attacks and all the basic things that happen within an organization every day. So what can we do to make their lives easier? And crowdsourcing can come to the rescue of this. It helps your security team level the playing field. Basically, you offer a reward to freelance security researchers if they're the first one to find and report an issue. And this is great, but automation doesn't replace people. But what if people were the new automation? Because scanners only go so far, and we know humans are much smarter, and these are the people who find breaches. But via crowdsourcing, it's now cost effective to utilize people at scale, the scale that turns it into automation. A simple example here is if you had 5 security engineers who are responsible for looking for bugs across your entire organization, your entire code base, that's extremely inefficient. Instead, think of it as 100, 1,000, even 10,000 security researchers finding vulnerabilities, and now your 5-person security team is just responsible for reviewing them, making sure which ones are valid, setting priorities, and passing them back off to your engineering and ops teams. And the great thing with this, lots of bugs become the best training that your dev team can ever get. They see what types of things are coming in. When they're writing fixes, they come to the next time they write a piece of code, they're thinking, I remember that particular issue that happened when this scenario came up. I'm going to do it differently this time. And this lets you make better decisions. So empowering this security team with aggregate vulnerability data lets them see which types of issues are happening in which parts of which applications. You don't get this from pen tests. They don't bring enough results frequently enough. Fixing 5 or 6, high priority issues a year doesn't make the dev team concerned about security. This aggregate data, knowing what users are where, this introduces less chest poking. It enables your security team to become more of a mentor so that your dev team can learn. And so if the goal is now around automating processes across these teams, having code perform functions that were previously painstakingly manual, how can we introduce a single process that fulfills needs across more than one team? This is an opportunity for huge cost savings. And the big thing here is looking for maximum value from a minimum investment. So one of the first things is to look at beyond this test-driven development that everyone's been doing. What can we do or other people have proven works? And so creating testable and reproducible server configurations is a big one. These scripts, that whether it's Chef, Puppet, Ansible, in Docker, these things can be used to build your dev instances as well as your production instances. So now you're sharing resources and assets amongst teams, joint ownership, more communication, more collaboration. There's a mountain of information that are contained in your application logs. So aggregating this and looking for anomalies, putting them in front of each of these teams, the dev, ops, and security teams, lets them all see what's going on with each other's pieces. And so then look at monitoring of the configuration of third parties. How do you know if your EC2 or AWS or Cloudflare configuration have changed? This is all really important things to know. And there's great open source and closed source tools and services for doing all this type of thing. And we'll send out a list of resources post-webinar. So a really simple way to think of this is build my application based on the fact that it's broken. But even better, just assume it's broken. Go out and light deliberate small fires in staging or the basic areas of your production systems. there's great tools out there for simulating these outages and breakages. Netflix has got a great selection within their Simi army. And of course, this crowdsourced security program is a great way to actually, highlight issues. Like basically the best way to make people care about security is to set it on fire. With the crowdsourced security program, you can do this in a controlled fashion. And the big thing to always remember is the best indicator of the next bug is always going to be the last bug. So if we summarize this up, take small steps that mean easy wins. Developers really have to care about the code that they're writing. And if they're not, then you're not going to get a good product. Security through this whole thing is part of the process. It's not a product. It's not a spend 3 months building something and then do a security review. This needs to be incorporated the whole way through. Don't wait for a fire before you hire firefighters. Just because you've instigated a firefighting team doesn't mean they have to be putting out fires all day, but have them ready, have them prepped. And you should be considering augmenting your internal team with a crowdsourced team. So thanks everyone for listening in today. We're a little bit shorter, which is great, so we've got plenty of room for questions.
Great. So we've gotten a few questions here. One of them here is how do you effectively start small simulated fires?
Yep. So one of the best ways with this is obviously a crowdsourced security program is great because if you're only currently getting 5 or 6 issues in each pen test that you're doing at the moment, being in a position to be able to have 30, 40 issues come in a short period shows much more awareness of, hey, there are issues here and we need to be considering how we're going to funnel this into our process. On the other side, running some of the tools that Netflix have put together, such as Chaos Monkey, Security Monkey, they'll actually highlight any of these issues that come up. So they can do things like simulate bandwidth issues, simulate servers, EC2 instances just dropping out of the system.
Cool. Great. We've got another question here. In relation to a DevOps team, I guess, how do you properly handle a breach?
So as far as a DevOps team goes, handling a breach is obviously a really big issue. And so ideally every company will have an internal CERT team. So a big part of that is making sure that it's something that you have an internal, emergency response team who's, have a process up front. The big thing there is have a process up front. I won't go into the detail of hey, how do we go about announcing this publicly? Do we announce it publicly? But the big thing there is have your firefighting team available to jump on this as soon as possible. Often this sort of thing means, security assessment, look at servers, look at code, identify what the actual core issue was here. And then obviously, there's going to be marketing people and so forth involved at that point. Next, basically be prepared.
That's a good question. We've got another one here. In DevOpsSec, does a security team drive security requirements and validate their fulfillment during the release stage?
Ultimately, what I'd like to suggest is that the actual security team is able to integrate their security requirements at the earliest stage. If an application is already deployed in production, it's probably actually already essentially it's okay, cool, all the code's completed. That's really too late to be driving security requirements. Ultimately, what would happen is that these types of requirements can be worked on during the time when the engineering team is working through a backlog or pulling items out for a sprint, having a position where possibly ideally the security team can come in and sit down while these engineering team is breaking up how they're going to implement these pieces, and that generally what's referred to as a sprint planning meeting, and being there in a position to highlight, hey, we really need to make sure that this thing is tied down, that we incorporate this particular service as part of this piece of functionality. And ideally what happens is that then the security team can have their own testing. So whether that's they're writing their own scripts to ensure that those security requirements are met, or actually work with the engineering team to actually introduce these abuse cases to show that those types of security concerns don't happen in the code every time it's committed. So again, coming back to ensure that there's security back at the code level and the data so that you don't have these things go into production?
That's a good question. We have another one in. It is, what are some examples of how we can run crowdsourced security?
Yeah, so there's a few different ways that people can engage with a crowd, so to say. A common one, which happens a lot, is the idea of a responsible disclosure or coordinated disclosure. So incorporating a page on your site where you're saying to researchers, I'm not asking you to come and hack on me, but if you did happen to come in, find something under these conditions, I will act this way, which is, I'll, be as helpful as possible. I'll work with you as long as you keep it quiet until there's a fix in place. And generally at that point, there's no reward whatsoever. It's more just, sometimes a little bit of credit on a page saying these people have helped increase our security. You can then step up to the idea of a bug bounty, where you're saying, I'm incentivizing you with dollars or sometimes, swag, if you're the first one to find and report an issue. And what we've found in the different disclosure and bug bounty programs that we've found, worked with Bugcrowd, is that responsible disclosure is great and that it finds some issues up front, but then people become a little bit less interested. Whereas when you run a bug bounty, the amount of input that you get from security researchers continues over time because there is that incentive.
Great. Are there any tools that you would recommend for automated security testing as part of a CI log monitoring for security issues?
Okay, yeah, I'll just repeat the question. Yeah. It's a good question. So we're always looking for new tools ourselves. So essentially there's two pieces. What automated security testing can I include in the CI system? And then what can I do for log monitoring for security issues? Both excellent questions. There's actually a Wikipedia page, which I'll send out after the webinar, probably early next week actually, that lists a whole bunch of essentially static security analysis tools, commercial and open source. So if you look at a few basic ones, for Ruby in particular, there's one called Code Dawn, there's another one called RuboCop. So these are both things that you actually include as part of your CI tests. So it'll run through and run a bunch of known bad code practices, and then also actually hit the site once it's in production and look for things like CSRF that's not being applied and missing headers that can cause issues. As far as log monitoring goes, realistically, there's way too many awesome log monitoring tools to use. The big thing there is looking at the log monitoring tools and setting up watches and graphs that represent the right things you want to be looking at. For example, 500 errors. If you plot the 500 errors across your site over time, it's a really good indicator of someone attacking you when you see a massive spike in 500 errors. Either that or someone else has introduced a bug. But either way, you want to be able to enable this firefighting team to be able to see this information all the time. As soon as there's a break in the delta of what those that were coming in, have alerts fire from your monitoring tool over to that firefighting team for more analysis. And ultimately what you'll find is there's a single or a few IPs that have started hitting you with a scanner, or they're doing it manually, or you've actually introduced an actual functional bug into the production system. But again, we'll send out some links for some great particular tools.
Okay, this is kind of a funny question we've got in. I guess the question is, who should be blamed for a security breach if one was to occur in your organization?
Yeah. I mean, this is great. I think one of the big things here is if an organization is standing around deciding who to blame when they have a breach or even if a bug in production, I mean, this is probably not the right way to think of it. The best thing here is to go, who's to blame? It's the whole organization, because they haven't incorporated the right feedback loops to make sure this sort of thing wasn't found before it went into production. Sometimes that can be hard. Complex systems, complex code, complex server infrastructures. We're talking you can have systems that run on 100,000 servers, and there's a lot of factors that go into that. Could be third party, could be internal. Ultimately, make sure that you're set up so that you can react quickly when an issue happens. If you can't deploy a fix or even spin up a whole new instance of your application in 10 minutes, then you've got some work you need to do. There needs to be something you can be striving for.
Great. We've gotten a few more questions. One of them here is, how do we make sure devs care about code? Some specific kind of hard examples is what this person is looking for. What are your thoughts on that, Chris?
Yeah, I mean, so a few of the things we do internally, and I mentioned a few of these briefly, but is like, if you can be in a position to empower the team, so very much around like give them the requirements for what the code needs to do, and then pass the responsibility back over to them. So having a team that's self-motivated, self-regulated, the idea of like having a system where in particular the code is assessed for like how clean it is. So there's a number of different tools you can use that will essentially lint code, and that comes back and says, hey, this is a bad practice. The team has agreed this is how we're going to lay out code files. This is how we're going to structure the architecture of files within the actual application, and being able to highlight that ideally to the whole team when someone is not adhering to this policy which the team has set up is one of the best ways to start. So now you've got your fellow teammates addressing issues that you're introducing, and so this helps definitely as far as like caring, and also improves the code quality.
Great. This is a good question because I think it sets realistic expectations. If my DevOps team can only do one thing, what should it be?
So if you were going to introduce just one thing, I would actually say start a firefighting team. Pick one person from security, operations, and dev to basically be on an email list.
3 people, one from each department.
One from each department. If you can do more, then more is great, but ideally one from each. And have each of those then be responsible for addressing any alerts that are raised, any monitoring alerts, to be the first people to triage any bugs that come in, whether that's bugs from customers or bugs as far as log stash and so forth. And having that team being there to be like, okay, cool. When you have these 3 people across each discipline of the tech stack are now responsible for resolving any of these issues. And this is not just about code. This is about like any security breaches, any minor security issues. Hey, we found some malware on a machine. Cool. Let a developer be part of the process to fix that up. It's about this cross-pollination. It's the most important thing. What we'll find is, and because these people are rolling through this every week, that they'll start to care more about what each other do, and then they'll actually start to look at ways they can reduce the work that's required of them when they're in this team.
Great. Thanks a lot for the questions, everyone. We've got a few more minutes. Does anyone have any other questions they'd like to ask? Again, Chris Raethke, interesting. You guys can reach us anytime by simply emailing us. Marketing@Bugcrowd is the email you guys can get in touch with, and I can make sure Chris is available there. So yeah, really appreciate you guys getting on. We'll stay on for a few seconds if there are any other questions that come through.
Yeah. And feel free to tweet to at Bugcrowd anytime during the day, over the next week, etc. Happy to answer any more questions.
Great. Let's see. Oh, you guys are welcome for the presentation. Thanks for that. We appreciate it. And we'll definitely make sure that we send out the video next week once we edit it, so you guys can have that available, as well as some of those resources that Chris has mentioned. So excellent.
Cool. Thanks everyone for your time today.
Have a good day.